So we're going to start with figuring out which values of x are going to make these expressions undefined. Now remember, they're undefined when your denominator is 0. So we need to figure out which values of x will make our denominators 0. So we can just take our denominator and set it equal to 0. So if we use 3/2, that's going to make our denominator 0, which would then make our expression undefined. Same idea here. We want to figure out when this denominator is 0. So we need to find two numbers that multiply to -10 and add to 3. So both the values 1 and 2/5 will both make this expression undefined. So now, using the same idea, we're going to find the domain of these same expressions. So these same functions. So notice this first one, our x can't be 3/2. That's because if we use 3/2, we would get something that's undefined. So that means x can be everything from -infinity up to 3/2, not including, or it could be anything greater than infinity. And all of these will work. Remember, domain is all the values that we can plug into our function. Any of these we can plug in and it'll work. On this second one, x just can't be 1 and 2 or 2/5. So that means it can be everything from negative. Now we're going to simplify expressions. This first part will be very similar to what we did back in chapter 1. So let's look at our coefficients. -12 divided by -3 is 4. Looking at our a's, we have a to the 4th in our numerator, 1a in our denominator, so we're left with a cubed. And then notice our b's. We have 2 b's in the numerator, 4 b's in our denominator, so we'll be left with b squared in our denominator. Notice we could cancel things that were getting multiplied. We have to use that same idea here. Notice we can't just cancel the x's or that 9 with the 3 because they're not getting multiplied. So the key thing is you want to break everything up that can be factored into its factored form first. So this numerator is a difference of squares. Now notice there's an entire factor of x minus 3, so we can divide that from both. And notice we are left with just x plus 3. So as long as it's a whole grouping or a whole factor, we can divide it out. So once again, we need to factor. Our numerator factors into 2x minus 3 and x plus 5. You can always verify these on your own. Denominator is 2x plus 3 and x plus 5. Now, which factors are exactly the same? Well, they both have this x plus 5. Notice these two are different, so we can't cancel them out. So we're just left with 2x minus 3 over 2x plus 3. On this one, it's slightly factored already, but we can factor this first part. We can take an a out. We're left with a plus 4. This second part factors into a minus 2, a plus 1. In our denominator, this a will leave out, and then we get a plus 4 times a minus 2. Now notice these a's can cancel, The a plus 4s can cancel and the a minus 2s. So we're left with just a plus 1. On this one, notice everything's already factored. This is a factor by itself. Notice these a plus 3s can cancel, but also this a plus 2 is in the denominator, so it needs to stay in that denominator, so it'll be 1 over a plus 2. Now notice that these two, numerator and denominator, are very similar, but they're not exactly the same. In the numerator, your n's negative, in the denominator, the m is negative. So let's factor out a negative 1 from our numerator. We're left with negative m plus n over n minus m. Now notice these two are the same thing. Your m is negative, your n is positive, so they can divide out. And we're just left with negative 1. And now this one, our numerator factors to 2a plus b and a minus 3b. Our denominator, notice they have a GCF of b that we can factor out. But notice there isn't anything that's exactly the same in your numerator and your denominator. But notice that these two are close. Once again, they're only off by a sign. So if we factor a negative 1 out in our numerator, we're left with negative a plus 3b. And now notice that is the same. So these two will cancel. So we're left with negative 2a plus b over b. Or if you wanted, you could have negative 2a minus b all over b. Either one is fine. So let's start by just remembering how we multiply and divide fractions. So notice with these first two, and the 12 and the 8, we can divide them both by 4, left with 3 and 2. And the 25 and 15, we can divide both of them by 5, and left with 5 and 3. And then you just multiply across, and we're left with 9 tenths. Now remember, when we divide fractions, we can change that to multiplying by the reciprocal. And so now with that 20 and 10, we can divide them both by 10, and we're left with 2 and 1. The 27 and the 18, we can divide by 9. We're left with 2 and 3. So we get 4 over 3. Alright, now, when we multiply rational expressions, it's the same idea, but before we can cancel out, we need to get factors to cancel. So we have to start by factoring everything that we can factor. So our numerator on the left, we can factor to a plus 3 times a plus 3 over a times a cubed over a plus 3. And now, notice this a plus 3 and a plus 3, that whole factor can cancel. And then this a can cancel with the a cubed, and we're left with a squared. So we're left with a squared times a plus 3. Now this next one, same idea, we have to factor everything that we can factor. So our numerator on the left will be a plus 3, a minus 2. Denominator's difference of squares, so it's a minus 3a plus 3. Numerator on the left is a minus 3 this time, a plus 2. Denominator is a minus 2a plus 2, difference of squares. Now our a plus 3's can cancel. Our a plus 2's, a minus 2, and a minus 3. When everything divides itself, we are left with 1. Alright, now this one, it's the same thing. We got to start by factoring. So the numerator on the left side, we can factor into x plus 2 times x plus 3. Our denominator, it's already partially factored, but we can't factor an x out of this first binomial. So we're left with x times x plus 4 times x plus 2. And if it helps, we can put this part over 1. And so now we can factor out an x squared. So we're left with x plus 4 over 1. Now notice our x plus 4s will divide out, our x plus 2s will divide out, and our x and one of the x's here will divide out. So we're just left with x times x plus 3. And now remember, with division, that's the same as multiplying by the reciprocal. So let's start by just changing this to a multiplication problem instead of a division. And now this is what we've been doing, so let's factor what we can. Notice over here, that's a difference of cubes. So it'll be x minus 2 times x squared plus 2x plus 4. The denominator is already factored. Numerator on the right side, we can factor out a 3x. We're left with x minus 1. And denominator actually does not factor, it's prime, so we'll just rewrite it. And now, let's look. This x squared plus 2x plus 4 will cancel. The x minus 1s will cancel. So we're left with 3x times x minus 2. This one, same idea. Notice it's over 1 already. So let's go ahead and change it to a multiplication problem by multiplying by the reciprocal, so 1 over a squared plus 3a. And now let's factor what we can. In our numerator here, we can factor out an a. We're left with a squared minus 9. But notice that's still a difference of squares, so we can change this to a times a minus 3 times a plus 3 over a minus 3 times 1 over, we can factor out an a, so a plus 3. And now, these a minus 3s will cancel, those a plus 3s will cancel, and these a's will cancel, so we're left with 1, because anything divided by itself is 1. Alright, this one looks intimidating, but it's very similar. We just have to start by changing this division to multiplication. So let's just start by rewriting it and changing it. Alright, now let's start factoring what we can factor. And so for this first one, it's going to factor into 2x plus 1 times x minus 1 over x plus 4 times x plus 1. This middle one becomes 2x plus 1 times x plus 2 over x plus 2 times x minus 1. And this last one, your numerator is x plus 4 times x plus 1. And your denominator is 2x plus 1 times 2x plus 1. And now let's see here. This 2x plus 1 can cancel with the 2x plus 1. Another 2x plus 1 will cancel with that 2x plus 1. X plus 1 divided by x plus 1. X minus 1 and x minus 1. X plus 2 is there, x plus 4 is here, and we are left with 1.